let's just jump into it. So I am a student pilot studying for my oral exam and my check ride. I'm just making some videos about different components to the oral exam that I just need to kind of keep refreshing. So these are one, just to help me get the repetitions in to memorize and learn this information, but also hopefully it can be of help to someone else who's working on an oral or just trying to learn about these topics. So let's jump into it. The first topic that we're going to be talking about in this video is going to be weather, my favorite. We're going to go over Prog charts, Airmet, Sigmet, fog, thunderstorm, wind shear, microburst, and then some icing. First, to start off, I'm going to pull up a Prog chart and we're going to talk just a little bit about what's on there and what it means. So I've got a Prog chart here. We see blue H's, we see red L's, we see lines, we see colors, we see shapes, lots of different things on a Prog chart. So to start off, we're going to talk about pressures. So we've got high pressure and low pressure. A blue H is going to be an area of high pressure. A red L is going to be an area of low pressure. And typically around high pressures, you have pretty good weather, pretty fair weather. It's, pretty calm. Around low pressure areas, that's where you get more of your severe weather. You get your storms, you get your hail, tornadoes, things like that. It's a lot of unstable air. Now, continuing to talk about pressure, we have these lines with numbers correlated in them. And those are going to be called your isobar lines. And they outline what the pressure is along that line. And then that number is going to be specifically what that number of pressure is along that isobar line. Now, moving on to fronts. And that is going to be these lines. They've got red line with little half circles. You've got blue lines with little triangles. Those are going to be your fronts. So a red line with red half circles is going to be a warm front. Typically, the weather that you're going to see around a warm front is going to be low stratus clouds, steady rain. It's going to be less dense and slower moving air. A cold front, and that's going to be this blue line with the triangles on it, that will be more of the severe weather. So, your thunderstorms, your hail, your tornadoes, cumulus clouds are going to be there. Next up, we have our stationary front. And this front essentially means that two fronts are kind of right next to each other, but they have equal pressure, and so they're not really able to push one way or another. And that on a Prog chart, on a surface analysis chart, is going to look like this line where it's got alternating red and blue fronts pointing in opposite directions. For a stationary front, again, since it's a mix of the two, it'll be a mix of the weather as well. And then last but not least, we have our occluded front, which is going to be a purple line with circles and triangles on it, purple circles and triangles, and that is essentially when one front catches up with another front. And similar to the stationary front, that is going to be a mix of both weathers. On the Prog chart, there are a lot more colors on there, but you can identify them based on the legend. Now let's move on to Airmets and Sigmets. So an Airmet is an airman meteorological information. And that's going to be weather advisories that could affect smaller aircraft, VFR aircraft, things like that. There are 3 items that Airmets cover. They cover turbulence, they cover icing, and they cover IFR conditions. Now, each of these is associated with a letter. Turbulence is going to be T, Tango. Icing is going to be Z, Zulu. And IFR conditions are going to be S, Sierra. Now, a Sigmet, that's going to be significant weather. So thunderstorms, dust storms, tornadoes, hail, things like that. Much more significant weather that all aircraft need to be aware of. And then as well, you also have your convective Sigmets, which are severe weather specifically related to thunderstorms. I'm going to briefly touch on fogs just to kind of scratch the surface of it. You've got kind of 4 types of fog typically. You have radiation fog, advection fog, upslope fog, and steam fog. First off, let's start with radiation fog. So radiation fog, according to pilotinstitute.com, forms at night when the surface cools, causing the air above it to cool as well. If the air has enough moisture, this cooling will lead to saturation and form fog. This typically occurs in the mornings when the ground is still cool, The fog will dissipate though as the ground warms up. Next up, we have advection fog. Now, advection fog forms when warm, moist air moves over cool ground or water. It is relatively shallow and often associated with an inversion. Advection fog differs from radiation fog because it may still form when there is a strong wind and cloud cover. Upslope fog. Upslope fog forms when moist air flows upward over rising terrain, causing it to cool to its dew point temperature. Like advection fog, upslope fog can be present at high wind speeds because of the increased lift and cooling. Steam fog. Steam fog, also known as evaporation fog, forms when cool air comes into contact with warm water. The warm water evaporates into the cooler air above, increasing the air's moisture content. When the moist air mixes with the cooler air, the water vapor condenses into tiny droplets, creating fog. So those are going to be your fog types. Again, something that I personally need to study a lot more because it's kind of confusing to me. All right, icing. 4 types of icing to be aware of: rime ice, clear ice, mixed ice, and frost. Rime ice is typically rough. It's got a milky kind of look to it. It's lighter than clear ice, and it results from instantaneous rapid freezing of supercooled droplets as they strike the leading edge. What results from rime ice is that rough surfaces decrease their aerodynamic efficiency. Next up, we have clear ice, and that is going to be clear and transparent. This type of ice is a lot heavier than rime ice. It is a relatively slow freezing of supercooled water. It's really dense, it's hard, and it's hard to remove. Third up, we have mixed ice. Mixed ice, as the name implies, is a combination of rime ice and clear ice. It's rough due to the rime ice components, but it's also dense and heavy due to the clear ice components. Both the roughness and the weight can negatively affect the aerodynamic capabilities of the aircraft. And last but not least, we have frost. So ice crystals form by sublimation when temperature and dew point are below freezing. And this is very dangerous, and it definitely needs to be removed before flight. If you see it, it dramatically decreases the aerodynamic capabilities and can result in stalls at a much higher airspeed. So those are going to be your 4 types of icing: rime ice, clear ice, mixed ice, and frost. Thunderstorms, microburst, wind shears. I'll go over this one pretty quickly. There are 3 stages of a thunderstorm. You've got your cumulus stage, your mature stage, and your dissipating stage. Cumulus, updraft, 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 creating those big clouds. Dissipating stage, there's a mixture of downdraft and updraft. So you've got that first bit of rain coming down. And then dissipating stage is when that rain is pouring out, right? It's all downdrafts, and your cloud is just kind of letting it go. Wind shear is very dangerous. This is the sudden and rapid change in wind speed and wind direction. And so this is something to be very careful about, especially if you are close to landing, because your airspeeds are low, right? And if the wind around you suddenly changes, you might go from having a headwind to now having a tailwind. And that just kind of affects your landing, right? It affects how you are low to the ground. So just be very careful about wind shear. Microbursts are very strong downdrafts, and typically the numbers associated with microbursts are going to be 6,000 feet per minute. So if your plane cannot fly 6,000 feet per minute, be very wary about this. This is something that's going to happen around thunderstorms, and it just is a huge downdraft of air that just can push you down. So that's going to be it. We covered Prog charts, we covered fronts and pressure areas. We talked about Airmet, Sigmet, convective Sigmet. We talked about fog, we talked about ice, we talked about thunderstorms, wind shear, microbursts, all the things. I hope this was helpful. It was helpful for me to go over. More to come.